Whoa! The Tau Herculid meteors might be intense. Have you heard? Well, we're going to break it down. On May 30th to the 31st, 2022, we might have a brief but intense meteor display thanks to a comet that split apart in 1995 and is apparently, well, still fragmenting. And it might happen as Earth passes through a particularly dense stream of particles which the comet may have left behind in the years 1995, 1897, and 1892. Who knew? And if this does happen, we will see a grand display of meteors. And even if it doesn't, this comet is one you'll want to come to know. Now, the meteor shower is the Tau Herculids. Its parent comet is 73P Schwarzmann-Wachmann 3, aka SW3. Now, these astronomers found this comet back in 1930. They were looking for planets and other stuff through old photographs, and they came upon this comet. And the comet orbits the sun every 5.4 years. And it just so happens that this comet will be in our evening sky again in July and August of 2020. It's not an intrinsically bright comet, but it's an exceptionally interesting comet. Back in 1995, astronomers watched as this comet began to fracture and litter its orbit with an increasing amount of debris. And that's why, by some recent calculations, this May 2020 Tau Herculid meteor shower spawned by SW3 might be an intense display. Now, this is going to be an all-or-nothing event. If the debris from SW3 was traveling more than 220 miles per hour when it separated from the comet, we might see a nice meteor shower. But if the debris had a slower ejection speed, then nothing will make it to Earth and there will be no meteors from this comet. But once again, if they ejected at a high speed, this might be the most spectacular meteor shower ever witnessed in modern times. So it's a good reason to get out and go look up. Now, after its initial discovery in 1930, and we're talking about Schwarzmann-Wachmann, or SW3, despite its relatively short orbit around the sun, no one saw the comet again until 1979. And you might ask, why not? Well, astronomers missed SW3 partly because its intrinsic faintness. And the astronomers were also looking in the wrong place in the sky. You see, their inaccurate orbital calculations were due to the occasional close sweeps of the comet past the giant planet Jupiter. Those close passes near the mighty Jupiter actually changes the comet's orbit. And then people began to see the comet again. With the exception of 1985, astronomers have caught the comet on every return near the sun since 1979. In 1995, Comet SW3 suddenly brightened by a factor of nearly 7 magnitudes. In other words, the comet suddenly got about 600 times brighter, and for a while it could be seen with the unaided eye. And, well, astronomers were baffled. A month after this outburst, observers using telescopes noticed that the nucleus or core of SW3 had split into pieces. They ultimately determined that the comet split into 4 parts, with 2 parts disintegrating completely and 2 parts remaining, still following the original comet's orbit around the sun. Now comes 2006, and then the return of the comet again, this time in 68 pieces. Now, by 2006, 2 things had become clear. First, the comet had by then fragmented into at least 68 pieces, 2 of which were still very large. And second, it was still falling apart. And that's where the story of the possible Tau Herculid meteor shower in 2022 gets even more interesting. For earthly observers, what can we expect at the comet's 2022 return? Well, certainly more than 68 pieces. But we don't know yet, and that's what we'll see when the comet comes back this year, in just a few days. Now, Comet 73P SW3 returned in 2011, but it wasn't well placed for observers that year, as it stayed mostly behind the sun. So we didn't learn anything from that passage. And in 2017, astronomers observed the main component C, along with one new fragment, BT. The nuclei, or multiple cores, of this comet are small. For instance, the largest part of component C is just about slightly larger than a half a mile, or about 1 kilometer in diameter. That's in contrast to a typical comet nucleus, which is about 6 miles wide. Now, will Tau Herculid meteors wow us in 2022? Who knew? Well, we'll know soon. First, a large number of particles must have been expelled from the comet's nucleus during its 1995 breakup. And this appears to be true, as images taken at the time indicate. Second, the breakup of the comet would have to have eventually pushed material forward in the orbit. As a comet orbits the sun and ejects material, let's assume that particles go in all directions. Those pushed backwards will assume a slower speed, and governed by these laws of gravity, they will fall closer to the sun. Since they are now closer to the sun, they will speed up, and in time, they will pass by the comet on their smaller orbits and get ahead of the comet. Now, images from the 2006 passage of the comet show, in fact, large chunks in a temporary orbit behind one of the other fragments. Finally, the comet must eject the material at speeds fast enough to assume this new orbit. At speeds of about 60 miles per hour are necessary to pull this off. This is faster than typical, but the major outburst and breakup of comet nucleus in 1995 may have been strong enough to produce these speeds. And then finally, if all three of these conditions had been met, we will have the perfect storm for the greatest meteor shower ever witnessed in human history, and a very short-lived one. Now, the radiant for the Tau Herculid meteors and this meteor shower got its name in 1930, when the parent comet for the shower flew by, very close to Earth. It's said that some observers saw the short-lived meteor shower in 1930, but that claim has been disputed. And since then, the shower has been either non-existent or extremely lackluster, although it's still on the meteor shower list of the American Meteor Society, which gives its duration as May 19th to June 14th. But this year, May 30th to the 31st, will be the only time to see what could be a historic meteor storm. Now, most meteor showers take their names from the point in the sky from which they appear to radiate. And this shower will probably be forever known as the Tau Herculids. And that was the location calculated when the comet was first discovered in 1930. But oddly enough, observers have never seen any meteors from this comet radiate from this location in our sky. And due to gravity of the giant planet Jupiter, the radiant has in fact wandered quite considerably. And it's now located in western Bootes, near the bright star of Arcturus, close to the globular star and cluster M3, which you see here. Now, how to watch the shower? Well, timing will be everything. In 2022, the new moon will be new the day before the shower was predicted to peak, so luckily, the moon will not be a factor in this event. Calculations by different teams have provided 3 different peaks, all within 22-minute time span. The most recent one places the peak at 5:04 UTC on May 31st, 2022, which is about 11 p.m. here, Mountain Time. Midnight on the West Coast, and even earlier on the East Coast, I believe. No, 2 a.m. You know how that works. The other two teams produce similar times of 4:55 UTC and 5:17 UTC. So it's right after sunset for most of the U.S., so get out and look up. Alert observers might also see meteors from previous visits of the comet, but with less activity than expected from the 1995 breakup. A slight increase in meteor counts might occur anytime between the 28th and June 1st. Dust from the comet's 1892 and 1897 visits may appear in the sky about 16 UTC on the 30th of May and 10 UTC on May 31st. The radiant will be high in the sky for much of the northern and central North America, but from northwestern United States and much of Canada, with the sun far north of the equator in late May, it will be twilight during the peak of the shower. What will the southern hemisphere see? Well, the radiant will be above the horizon for all of South America during the peak of the shower, and you're looking at the current peak viewing region. The radiant will be lower in the sky as seen from the southern hemisphere than from the North American position. So the number of meteors will be fewer than if observed from the northern hemisphere. So that makes us the big winner chicken dinner. On the other hand, with the radiant low in the sky, observers might spot some earth grazers, long path meteors traveling through the sky from the radiant. Now, how to watch the shower? Well, a dark sky is essential. This potential meteor shower will be short-lived, so don't be late to the star party. Find a dark site from which to observe and take time to get dark adapted. Note that these meteors will be slow-moving, as they will have to catch up with us as we orbit the sun. With their slow motion, the meteors will be dimmer than they would be if they were moving faster in relation to Earth. Meteors from this shower will trace back to the radiant. You will see other meteors too. If they do not appear to come from the radiant, they are not true members of the Tau Herculid meteor shower. Now, the meteors will appear to travel away from the radiant in the sky. That does not mean they'll be only in the part of the sky where the radiant is. You're likely to see a great number of meteors while watching about 45 degrees from the radiant and about 45 degrees high in the sky. If you have a telescope, look for Comet SW3, located 47 degrees west of the meteor shower radiant. It's part of the sky occupied by the constellation Leo. The comet will be faint at a magnitude of 11. Will we get a wonderful meteor display? Well, we know that the comet has been fragmenting, and fragmenting at greater and greater rates every 5.4 years. The last time we saw it, 68 pieces. So this time it should be double or better. And any time spent under the nighttime sky is never time wasted. So if nothing happens, well, you got out there and you looked up. The bottom line, Comet 73P, Schwarzmann, Walkman, 1995 Outburst and Breakup may produce a wonderful meteor show May 30th to the 31st, 2022, right after sunset for most of North America. Look up north and then look 45 degrees north towards Arcturus and just left and down. And that is the radiant for Tau Herculids. I hope you got something out of the video. This may be one of the most spectacular meteor showers ever witnessed and short-lived. Or it may be nothing, but it's worth the chance. It should be warm, the moon won't be in the way, and we have nothing to lose but to get outside, get some fresh air and Shinrin-yoku, and look up for what may be a spectacular event in the night sky. And that's a boom to knowledge. Subscribe to the channel if you haven't. Share this with like-minded people. And be safe. We love you. Thank you to our Patreons, our new Patreons. Without you, we can't do this. Consider becoming a Patreon and give a small amount each month to support the work we do. We love you. Be safe. Boom.